Hello, I'm Ford Dennison. I'm an evolutionary biologist at the University of Minnesota, working to improve the benefits that crops get from symbiosis. And I'll share my screen. So bacteria and root nodules provide legume crops with billions of dollars of nitrogen. This is the reaction they carry out. They take nitrogen gas that diffuses into the soil. There's a cost of hydrogen and electrons that they get from ATP, and they produce ammonia, which is like the fertilizer that farmers use, and hydrogen as a byproduct. The bacteria are housed in root nodules like this, and the nitrogen that they provide eventually ends up in protein in seeds like soybean. But to increase those benefits, we have to recognize that bacteria, different strains of bacteria, vary in the benefit to cost ratio. The nitrogen benefit, but there's a cost to the plant for operating root nodules and also for construction of those nodules in the first place. And that's the cost of carbon that the plant could have used for something else, like soybean oil, for example. Now, we've developed methods to measure the operation cost of nodules. That would be the amount of ammonia that they produce relative to the amount of carbon that they respire. And you can see in these data from a recent paper that this strain of bacteria, which has a knockout in a normal gene, is substantially more efficient in terms of how much nitrogen it's providing relative to its cost. But there's also the cost of making the nodules in the first place, and that's roughly proportional to the nodule weight, which is plotted here. And I've plotted here old data from 1964 of soybean yield as a function of nodule weight per plant. And the soils are full of a bunch of different rhizobium strains. Now, farmers might apply this strain as an inoculum. It provides a large benefit at a relatively low nodule construction cost. And then there's some other strains that are, not too bad. There's some down here that don't provide any benefit, but they also have negligible cost. They don't make very many nodules. And then the ones we worry about are ones like this that have a high cost, but a relatively low benefit. And so the question is, how good are different soybean varieties at either picking which rhizobia, which of these bacteria they pull out of the soil in the first place, or preferentially supporting the ones that provide the greatest net benefit. Now, we do know that if they get a bacterial strain that doesn't provide any benefit, that they shut down those nodules. And we can see that here. Here are nodules that have a strain that is providing nitrogen. The plant supports those nodules, and so they grow, provide nitrogen, but at some cost to the plant for nodule growth and operation. Whereas these nodules had a strain that didn't provide any nitrogen, and the plant shut them down as soon as it noticed that, and they didn't grow anymore, didn't have any further cost. And we've seen that effect initially in soybean, but also in pea and alfalfa, that the nodules that aren't providing any benefit get shut down, the rhizobia inside don't reproduce, and so they aren't released into the soil to plague future generations of soybean or alfalfa on the same field. Unfortunately, many of the rhizobia that are out there fix some nitrogen, but they're kind of mediocre. And the current varieties mostly seem to support those mediocre bacteria as if they were just fine. And we can see that in the reproduction of the rhizobia in the nodule. That's the vertical axis here. And here we've actually controlled the rate of nitrogen fixation. 100% is good. 0 is bad. And if they don't fix anything, you see that they stop reproducing pretty soon. They only have maybe a third as much reproduction. So next year there'll be 3 times as many of the good strain in the soil. But mediocre performance, as shown here, fixing at only half of the ideal rate, still those rhizobia in current varieties seem to reproduce just as much as the very best strain. And that's probably why the mediocre varieties are able to persist in the soil, is that the soybeans continue to support them. But working with a plant breeder here, I'm hoping that we can change that and get soybean varieties that would shut down all but the very best bacteria. And this is where AI comes in, because, as I say, we've got a method for measuring nodule function cost or operation cost, but the nodule construction cost, the weight of nodules per plant, is actually something that's quite expensive to measure in terms of labor. And so people really haven't been doing that until now, that with this new program, RootPainter, that Abraham has developed, we're able to automate that process. And so we start out, we've got plants growing here in a growth pouch where the nodules are visible. Over here, I've got a camera, and it's all connected to a Raspberry Pi computer, which is connected to the internet. And so it could take pictures and automatically upload them. And so then we get an image like this here on the left, run it through the RootPainter artificial intelligence program, and it's identified all the nodules, marked them in red, generates an output file, which I then feed to a Python program that adds up nodule weight per plant. And I'm actually trying to do a bit, which is, the overall cost, but I'm actually trying to do a bit more with that and actually track the development or the growth of individual nodules. So I could see, for example, if this nodule is not growing as fast, and it's because it has a mediocre strain of rhizobia in it relative to, say, this nodule there, that's what we want, is a soybean variety that would let the good strain grow fast and shut down the bad strain. And again, here we're showing difference in growth between a very bad strain not growing at all, and currently a good or mediocre strain would continue to grow. But we're hoping that using this system, we'll be able to measure nodule growth in a way that'll let us identify soybean genotypes for a plant breeding program that will shut down all but the very best nodules. So I will stop sharing and stop recording.